So this is the top PCB where, well, our section in ESA has a contribution. We have three instruments or three sensors here. We are trying to do science in three different ways. So the blue PCB, the small one, is a pressure sensor, which allows us to measure the pressure inside the CubeSat down to 10 to minus 6 millibar. So it's mostly relevant in the beginning of the mission after launch. Well, we will be able to see the decay of pressure inside the CubeSat or the Woodsat. Then next to it, the brown looking plastic, it's PEEK. So it's a 3D demonstrator of 3D printed PEEK. And the idea is to have a conductive path made out of conductive PEEK, so closing the circuit. So we'll have a sensor inside, the light sensor, and we are acquiring the signal, and we will be switching on and off an LED, so we will be able to see the signal increasing.
And what is PEEK?
PEEK, it's a polymer. It's a very sturdy polymer. It's used in space applications in different configurations, actually, because it's very robust and it's easy to, well, not easy, but it's possible to build with a 3D printer. And it has a set of properties that is actually extremely interesting for space applications. It has low outgassing, it has high mechanical robustness, let's say, so it allows you to make parts that are quite strong for plastic. And then you have the white sensor here, which is a QCM. It's a quartz crystal microbalance, and allows to measure the contamination levels. So it's a very sensitive crystal which is resonating at a certain frequency, and when contamination or when molecular when any mass deposits on the surface, it changes the frequency, and therefore we'll be able to see as a function of time what is the buildup in terms of contamination. So it allows us to measure the contamination environment inside the CubeSat. Well, the wood is for sure something very interesting because it's the first time, and we would also have, I mean, there's other possibilities or different perceptions that we can have in terms of materials used. So it's light, it's flexible, so it can have different applications. So that's the mission environment will also drive the applicability or not of wood, of course. So in terms of radiation or in terms of temperatures that the satellite would see. In terms of CubeSat, it's obviously an interesting way. It's a standardized manner to achieve, to get access to space. So,
what is interesting in this mission from your point of view? Why are you investing so much for this little instrument suite?
Well, actually, it's not every day that we have the opportunity to fly something that we helped designing. And in our group, we thought it would be extremely interesting from the science point of view to understand a bit more the venting processes inside the CubeSat. So that's why we thought that the pressure sensor would be very interesting. But in terms of contamination control, it's also an important area nowadays because there are many sensitive instruments that are flying, of course, and the tendency is that more and more instruments are more sensitive, so we have to have a better understanding of the contamination point of view, and that's why it's interesting to find a different suite of instruments, or let's say that this is an ad hoc or a customized version of the QCM that could be developed for this project. And as far as for the 3D demonstrator, it's also extremely interesting because we could then prove the feasibility or the actual possibility of using PEEK as an active element in the circuit, being conductive, electrically conductive, and this could open the doors for other possibilities. So there's different demonstrators in the mission or in our payload, and we are excited about having this possibility.